Hello friends, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of problems such as dynamic programming, breadth first search, depth first search, and some of the playlists are based on the data structures such as trees, graphs, linked lists, and so on. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can get the link from the description below this video. Let's jump into today's problem. Delete node in a linked list. Write a function to delete a node except the tail in a singly linked list, given only access to that node. Given linked list head 4519, which looks like following 4519, right? So basically we are asked to delete one node in a linked list. So the catch here is we are not given the access to the head node, but we are given access to somewhere in the middle, and we have to delete that node. So for example, if you go to the example 1 and look at this linked list, right, 4519, it's same as whatever is shown in the picture, and node given is 5. So basically we need to remove the node 5, and once we remove the node 5, the contents will be 419, right? So that's what it will be after. So if you go look at the example 2, it asks to remove node 1. So if you remove node 1, right, it will be 459, right? So that's what it will be. So that's the problem description, right? So we are not given the head of the access to the head of the linked list. So we are only given access to the node which we are supposed to delete, right? So normally when we want to delete a node in a singly linked list, so that's also one more important point, right? So if it was a doubly linked list, we know we have the access to the previous node's pointer also, right? But in a singly linked list, we don't have access to the previous node. But without access to the previous node, we won't be able to carry the delete operation. We must need access to the previous node, right? So that we can connect whatever the previous list with the list what it is after deleting this, right? So in this example, so 4519, right, when we delete 5 in this case, right, so there will be two lists that will be formed, right? So something like this. So if we deleted 5, right, so there will be two lists that will be formed. So we want to join those two lists. How can we join? If we don't have a pointer to the previous node, we won't be able to join those, right? So ultimately, yeah, if we remove this, we want to join the previous list with the list by splitting at the at the deletion point, right? So we want an access to the previous pointer. So since we are not given the access to the previous pointer, the regular deletion method won't work. So we must create a sort of previous pointer somehow, right? So we must create a pointer to the previous node somehow. So what we are going to do is we will do a technique of shifting the values. Okay, so let's take that off, and we have the same thing. Okay, and we are asking, so node 5, right, that is example 1. So node is 5, so we are asked to remove node 5. So the resultant answer will be 419, right? So what we are going to do is copy the nodes after 5 and shift them one by one, right? So what I'm saying is, so this is starting, so initial, so given, right? So what we are saying is, so 1, copy it over, right? And 9, copy it over. So 9 will be there. So for 9, since that is the last element, you cannot copy it anyway. So the linked list will become like this, and you can just delete the last node. So once we delete the last node, what it will be? 1, 9, right? So this will be the answer that we want, right? So this is the shifting technique. Basically, you are deleting the last node by shifting all the values subsequently after the node that you are given access to, right? So you are given access to 5, you copied over all the elements and you delete the last node. So this is one approach, right? So this will take the order of some complexity, right? So the time complexity would be, since we don't know the number of nodes in this particular linked list, we would say, okay, whatever the number of nodes after 5, right? So whatever the number of nodes that after 5, let's say there are n nodes after 5, right? So that would take order of n time complexity, right? So order of n time complexity, where n is node count after 5, right? So in this case node 5, so after the node to be deleted, right? So that is 5 in this case, right? So let's try to improve this, the same technique, and see if we have to really copy over all the elements or not, right? So that's one thing. So what we can do is, so we are given with this, right? We are given with this. So we shift and copy, okay? We shift and copy. So that means we have 1, so sorry, it will be 1 and 9, right? So this will be first after the first copy, right? So first, once this element is copied, that will be the first after first copy, after the first copy. So obviously after the second copy it will be like this, right? 9, 9. So this will be second copy, right? That's what we went through, right? So what is there in the line 24 above, right? So what we are going to see is, we don't have to do this copying at all, right? We don't have to copy this at all. Once we have the first copy, what we can do is, all we have to do is, since we have already copied this one to here, we can delete this one node, right? Whatever the copy that we did, we can just delete that. So delete the copied node, right? So what it will become? 4, 1, 9, right? So this is what the answer that we want, right? Simple. Yeah, this is what the answer that we want, right? So 4, 1, 9. What we are saying is, we just copy over whatever the next element for the node into the current element, right? So delete the next node, right? Delete the copied node, right? That's it. That will be our answer. So this will be how many operations that we are doing? Just one copy and one delete. That's it. So it will be order of one operation, right? So we have improved from order of 1 n to order of 1, that is linear time to constant time. So all we are doing is just copy one element and then delete that copied element, the next element, basically, right? Done. So that will be a very simple code to look at. So let's go ahead and look at the code. So we have a list node temp. What I'm putting is, in temp node.next node next. What is that node.next? So in this particular case, we have node.next is this. So that's next pointer is this. So 9 we are keeping in the temp, right? And node.value, node.next.value. Node.next is, node is 5, right? Node.next is 1. So node.value, we are copying it to the node.next.value. So 1 is being copied in place of 5. That's what we are doing here, right? And then node.next is equal to temp. So what is node? Is still pointing to 1. Next, this dot next is equal to temp. What is temp? 9. So we are pointing this pointer to 1. So basically, if I have to represent in a visual way, right? So let me put in the visual way, right? So it's like this, right? So, right? So what we are saying is, right? So this is what we are trying to point, right? Exactly, this is what we are trying to point. 1 is pointed to 9. So this 1 will be lost now, right? So coming back, so that will be it, right? So now this visual representation is gone. That's it. So that's how the representation. This is a very simple code which can be done in order of one operation. So that is the time complexity, right? Time complexity. So what is the space complexity? We are just using a temporary node, right, for this operation. So this is like again a constant space. So space is also constant. So space is also constant and time also constant. So this is a constant time and constant space complexity algorithm. So if you have any questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted the code to the GitHub repository. You can find the link in the description below for the GitHub repository. If you haven't subscribed to my channel yet, please go ahead and subscribe and also share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye. Thank you.